Yeah, how's everyone doing?
Good.
Last talk, right?
More after this.
One more. Is there? Okay. Well, if you need to get up, stretch, walk around in the back, that's all fine. I do that all the time. It helps me pay attention. It's going to be pretty casual here. Unlike the previous presenters, like working for these like famous projects and these super polished applications, I kind of hacked this together myself, and so this is very much like the like a DIY project. But the themes are very similar to what we've been talking about this whole afternoon. I think we could have probably renamed this part of the track like the wrappers around JavaScript track or something like that, right? So yeah, how many of you guys love the capabilities of JavaScript when it comes to making visualizations in general? It's awesome. And how many of you guys like writing the JavaScript code? Yeah, exactly, right? So as like Python developers, we kind of sit in our chairs and we're like, yeah, I want that. I want that from JavaScript. And I want to make web applications too. And then I want data in Python objects. And I want, very demanding, I think we can be. But the result is, that you have this great synergy of like all these different technologies and you get to like put them all in one project and deploy it and like kind of carry it from beginning to end. And that's kind of what I want to show. I kind of want to show this idea that I had to look to use API data from the Washington Metropolitan Area Transit Authority as well as Walkscore, and kind of like incorporate that with maps and make a little application that helps us visualize a city a little bit differently. All of this stuff is on a GitHub repository. It's up here. Hopefully you can see the address so you can follow along. There are a couple things you won't be able to do until you get an API key, but there are, for example, for WMATA, they have a guest API key. So if you just want to play around with this tonight, you can just go copy this from their website and hit their API with it. It's obviously going to rate limit you if you try too hard, but yeah. So what I want you to take away from this talk really depends on what you're bringing to the table. Okay, so I'm going to jump into detail into a bunch of different things, ranging from Flask deployment on Heroku, which we just heard a little bit about, to geocoding, to Choropleths, whatever. If you have some expertise in these areas, feel free to focus in on that. Otherwise, just pay attention to the big picture and like how we're trying to like bring these ideas back into this like main project that we're working on. So you can so you can focus on the details, you can focus on the big picture, you can focus on both, you can focus on neither and just enjoy the pretty pictures. I enjoy doing that too sometimes also. Cool. So I think we're ready at this point to jump in. Yeah. So all the basic boilerplate out of the way, package management, Git, Jupyter. I think we can skip all of that stuff. How many of you guys think maps are art? That's a pretty high percentage. Yeah, I often think about maps and, whether there is a distinction between art and like practical visualization. In some sense, maps can be like data frames, just like pandas, but indexed by latitude and longitude, and then a whole bunch of features, right? But they really allow for a lot more abstract thinking, I think, than just looking at a data frame. This is a map of, what do you guys think this is a map of? It's actually a map of submarine cable, like the underwater fiber optic and other kinds of cables that carry data all around the world. These people actually put out this really cool comparison chart between a map like this and trade route maps from like centuries ago. And you can like notice the similarities and differences. So I look at something like this and I'm like, yeah, it's showing me data. but it's showing it in a way that like immediately brings up all of these other contexts, right? Context of history, context of geography, context of the world. You can see like just by looking at where these cables are, you can kind of get a sense of like where people are. So I think obviously maps are very powerful. I probably don't have to spend any more time convincing you guys of that. So so let's just jump into how we can like make maps that are as beautiful as I think this is in Python. And so the answer is going to be, like everything else, a wrapper. And we are going to wrap a JavaScript mapping library called Leaflet. I'm just going to run all the things here. It's my favorite button in Jupyter. Restart kernel and run all. The JavaScript library is called Leaflet. And if you've been like looking at these other talks and like how do they deal with these cool sliders and widgets and they click on stuff and things happen, all of that is JavaScript, right? JavaScript is this engine that connects what the user is doing in a web browser to some back-end logic and can instantly communicate between the two so that you don't have to like refresh a web page to get a new map or a new visualization. It just instantly updates. And so if you look in the Leaflet documentation, you know, you'll see things like, okay, here are events, and it's like listening for somebody to move the map, and it's going to trigger some action when somebody stops zooming or something like that, right? These are all of the ways that we can like get interactivity into our maps in JavaScript. And so we're going to have that same interactivity in the Python version. I'm going to split this up into a few little mini projects just to prevent this from being too overwhelming. So the first thing we're going to do is just look at some basic bus tracking. I'm going to skip through some of this. There's some exercises in this notebook and stuff like that you can try at home. So when I say bus tracking, I mean I want something that will show me a map of where buses are in DC right now. That's what I want. So the inputs are some location of interest, and some search radius around that location is also helpful for like limiting the scope of this. And our output is like the location and information about the buses in that area. So the first thing we're going to need to do, and this is the first of those little subtopics I talked about at the beginning, is something called geocoding. Geocoding, I like to think of it as, I don't actually know what it's short for, but I think of it as like geographical information encoding, right? I want the geographic information encoding of a thing, right? So if I have a location, if I have some place like Union Station in DC, I want to be able to ask a geocoder, what is the geographic information associated with Union Station? And it should spit me back something like this. This is the address of Union Station. This is the city. This is how confident I am about this being right. Country, icon, some of the most important, probably latitude, longitude for doing mapping. And other things like neighborhood, right? Place ID, postal code, a whole bunch of stuff. So where does all this information come from? Sure.
Company I have.
Yeah, well, they probably have their own geocoder at the Geographic Intelligence Agency. There are a lot of different geocoding providers. Okay, Google has one. They don't. I think you kind of can't get it for free anymore. This is the OpenStreetMap geocoder. It's OSM. This geocoder package, which is a Python library I imported at the top, is just something which makes it easier to manage the requests to and from these geocoders. So geocoder.osm is a shortcut for a whole bunch of like HTTP requests to and from the OpenStreetMap URLs. So this is a nice kind of convenience function. So this data is only as good as OpenStreetMap is, and actually the Google geocoder is a lot better at like figuring out what you mean by these location strings. Like I can type in the Google geocoder, Capital One headquarters, and it will probably figure out that I'm talking about this building. But if I try to type that into the OpenStreetMap geocoder, it might be like, sorry, I couldn't really figure out what address you're trying to talk about. And we might see an example of that later in the app. We almost certainly will, because I'm sure it won't work. So we have all this information now, right? We've got all of these fields now. And the idea is like, now let's make a map. In Folium, maps are hierarchical objects, okay? You make a map object, and then you add things onto that object. You can think of it as like you make a canvas, and then you're going to like put things onto that canvas. So all I'm going to do here is I'm going to make an object called bus map, and it's a Folium map. I'm going to initialize it with a location, which is the latitude and longitude that I just got from the geocoder. And I'm going to start it at a certain zoom, because otherwise you might end up looking at like the Earth or like a block. And then I'm going to add a child to that map, which is a Folium marker. All of these capital map marker, these are Folium, imported from Folium. And the marker also has a location, but I also can give it pop-up text, and I can give it a custom icon. I can color that icon. And then I'm just going to type bus map in Jupyter Notebook, and I'm going to see a map like this. I really should not scroll using the touchpad on something like this. So this is what I see. This is Union Station in DC, right? And I've got a little pop-up marker here saying, OK, here's the address. So this is not magic, but it is kind of nice, because this map is scrollable. And I can go however far I want here. I can even go all the way to Capital One headquarters if I could find it. If I know my Virginian geography, which I don't. Here. So we are like right around there. And if I wanted to go look at other countries, I could. I could just keep scrolling. I could do whatever I want in this map. I can zoom out. I can zoom in. And so this is kind of like the benefit of tapping into that leaflet interactivity, right? Because this is JavaScript, I can actually update this in the back, or update this on the notebook, and the information is like dynamically being retrieved from the internet in the background. And you'll notice like there were some people talking today about like tiles. You can see these tiles loading on the edges, right? It's dynamically updating that. So that's pretty cool. And the other nice thing is that this is in a notebook, right? So how's this in a notebook? Well, it's because Folium is it's really just spitting out HTML, right? And the notebooks can handle HTML. They can render HTML. And so this is basically just a big blob of HTML code, which is largely JavaScript, to be honest, that you can basically embed anywhere. You can embed it in a notebook. You can embed it in a website. So that's like the portable part of what I'm trying to talk about. And we could look at what this looks like if you're kind of masochistic and you want to see what this is. There's no point zooming in because it's worthless. But all of this is like a map, right? Every one of these things is representing like a polygon or a marker or a tile or something like that. That's what I mean by like JavaScript blah. But I don't have to touch it. I don't have to write it. I don't have to maintain it. I can just enjoy the benefits. OK, so that allows us to also save these files, right? So I could save this as HTML. I could email this to somebody. They would have the same scrollable, zoomable map with the pop-ups, with the text that comes up when you click on it. All of that stuff would still be there. So that's Folium, the basics. All right. Now let's talk about pulling in some extra data and essentially doing some joins on live API data. So for those who went to the web scraping talks that there were on yesterday, you might have noticed that there were some really good talks about like responsible scraping of the web. I have not built in these checks here, so this is like very much do not necessarily copy this, but the principles are the same. I'm going to start up a request session. So request is just Python's way of interacting with HTTP requests. And I'm going to point it to the WMATA API. And I'll be nice, and I'll stop retrying after 2 times if they don't respond. And I'm going to structure this request the way they want, right? Just go to their API site. It's very clear, easy to use. You can figure out how they want the request to be sent. And you can put your API key in the right place. You can make the right keys and values to get something out. But the nice thing to do, the really nice thing to do, would be to not have to make the same API call twice for the same data. Like every time I run this notebook, why should I hit the WMATA API again for the same exact information? And so one of the things I built into this project as I was kind of like assembling the Frankenstein's monster is some ability to cache API calls, right? Especially when an API is free, like you shouldn't be hitting that more than you really should, more than you really need to, right? It's like the tragedy of the commons thing, which was in the keynote from the very first day, right? Eventually, somebody's going to be like, all right, well, too many people are abusing this free API, and we're going to take it away. So editable pickle is one kind of way that you can do this in Python. There's many ways to do it. Editable pickle, the way it works is it literally gives you a decorator, which you can wrap around your functions. And then the output of that function will be pickled and cached in a location that you specify. And it's cached based on the function inputs. So you can see that here I basically templated argument 0, 1, and 2 for this function, which corresponds to latitude, longitude, and radius. And so it's going to make files like some latitude x some longitude underscore radius some number dot bus list, and it's going to put them in a cache directory. And then editable pickle, when I run this function again, it's going to look in that directory and see if there's a file that matches the inputs that that function was just called with. And if there is, it will just load the unpickle the result and return that as opposed to executing the function again. So very simple kind of memoization type stuff. You can play around this yourself by adjusting this keyword. If you do refresh equals true, it forces it to recalculate the function. If you leave it false, then it will just get it from the cache. Because this is cached, I know that there's going to be a bus heading to the Kennedy Center on Massachusetts Avenue. This one. That's been there every time I run this demo notebook because I don't need to hit their API over for the live data right now. And just an example of what the JSON looks like from the API when you get the response from WMATA. I probably will gloss over this in the interest of time. But you can see that this getBuses function, I put in the latitude, longitude, and radius, and I get back out a whole bunch of bus objects. And one of the bus objects might look like this with a vehicle ID, location, where it's headed, whatever. So then all I'll do is I'll just write a for loop, and I'll add to the map every bus that I found in this area, right? So that's how I'm making these little polygon markers. And so I can see that this is like, different routes of buses going different places. So pretty cool. That's the bus tracker part. Everyone okay with that? How we pulled together this API and caching and the map and all right, not too bad, not too bad. So let's do aggregations, right? That's what everyone has to do next. That's what you do in most data analysis, right? Let's aggregate. When you're talking about maps, aggregations sometimes boil down to drawing lines on those maps and thinking about regions. So how do we do that in Folium? The motivation for this part is really just looking at some census data. Census data is really nice, clean data set that has geographical information and properties about each of these geographical areas. So what I'm going to do is I'm going to load a GeoJSON file that I just found on the internet. GeoJSON is a JSON that describes a region. So what does that mean? Well, it means that instead of before where I had latitude, longitude, and some information about that point, now I have a whole bunch of coordinates. And these coordinates taken together basically draw out like a polygon, right? Each coordinate is like the vertex of the perimeter of the polygon. And then I have some properties about that area and what its population is in general. This population is 709. So I have these for every neighborhood in DC. That's what this GeoJSON file gives me. So how do I map this now? Well, one thing I might want to do is color these areas based on these properties, right? Let me assign a color to each population so that if it has higher population, it's like a deeper shade of green or something. And so color mapping is a kind of interesting decision that you have to make when you do this. Color brewer is one really nice way to think about this. Probably not enough time to go into the details of this whole process, but suffice it to say, you can figure out like some nice palettes for the information you have, depending on whether it's like sequential or diverging or qualitative data. You might want to choose different colors. Depending on how many classes you have, this is 3, for example. If I crank this up to 9, you can see how their palette interprets that and where they make the breakpoints. And they're trying to do this to like maximize legibility. You can still kind of see the difference between each of these different classes. And it just looks cool. You know, it's better than just like randomly assigning colors, red, green, blue, yellow, you know, whatever. So we can like access this in our notebook as well. We import these linear color maps, and you know, we can choose a linear green-blue scale, a purple-red scale. We'll scale them according to the minimum and maximum of the population and the poverty rate. Those 2 of the attributes we have in the census. And we will then make a Folium map. We'll add a little caption that shows a population scale so that people are not so confused. And then we'll just call Folium GeoJSON and put our JSON data in and basically tell Folium that we want to style this region based on this Lambda function. And so when we say fill color is this pop colors is our color map, and it's translating between the number of the population and some color hex, right? That's what this is showing up here. So what you get out of this after I add some layer control, which will just give me a little bit of be able to click these layers on and off, is something that looks like this. So I can look at just population, and so this is the green-blue range. And you can see the scale at the top, which kind of shows like population 0 is kind of in green, 5,000 is kind of in blue, and you can see all of the regions with dashed lines that came from the GeoJSON. The tiles are different because you can specify the tile type in Folium. So this is like a less colorful map so that the colors are more evident when you color the regions, right? You wouldn't necessarily want to make these colored regions on the first map that we had. And the layer control lets you click these layers on and off. So I can look at just the poverty rate by region, I can look at just the population, or I can overlay them. And then the cool thing about this is you can kind of like overlay blue and red and get a kind of intersection type of query where you're looking at looking for purple regions where the poverty rate is high and the population is high, right? And so then you can kind of like look at this from a bird's eye view and get a sense of your data. But we can do so much more because this is in Python, right? So what if we want to make some custom properties for these regions? Well, let's open this up in pandas, right? Let's just take a pandas data frame, which we made a little bit earlier. We made a pandas data frame here. We cycled through all of these neighborhoods in the GeoJSON and like extracted out the properties and made a pandas data frame of them. And so down here, we can create a population density variable now that like normalizes by the area of the region. And then we can update the GeoJSON. So we go back into that GeoJSON like massively nested structure and add a property for density to each one of these regions and then remap it. And then we'll see something like this. And if you go back and compare these maps, you'll notice that like there's a lot less purple over here, east of the Anacostia and south of the Anacostia, because even though there's quite a lot of population out here, the regions are bigger, and so the density is lower. So like you can think about different ways you can structure these queries to get at the exact kind of information you want. And you can use whatever processing you want in Python to do that, and then have that reflected in the map. So is everyone still with me? All right. Yeah, so the sky's kind of the limit for this kind of thing. One last example in a couple minutes I'll show you is Walkscore. By this point in the project, I was kind of thinking, there are so many ways to visualize this, right? There's so many ways to look at what the city actually means. Maybe I shouldn't limit myself to these political boundaries, right, that the census gives you or that the city gives you. You always see this diamond in DC, And so how can we visualize cities in a different way? This is just a side note from the Core Plus stuff. This is something else you can do in Folium as well. Just add a slider that cycles through different values as time changes and link it to the timestamps so that you can kind of scroll through time and see how things change on your choropleth. Pretty cool. All right, so different ways of visualization. Have you guys seen this map before? This is a map of the US, but the only thing being mapped here are bodies of water. Right? There's no streets, there's no state boundaries, there's no coastlines. It's just rivers, lakes, streams. And so I'm thinking about along the same lines with Walkscore. This is the New York Times they came out with this recently. It's like every building in the US, right? Again, there's no streets on this map. It's just buildings. This is Chicago. I used to live in Chicago. I love the grid. You can kind of see, I hope, just how grid-like it actually is. And you can also, we can actually go back to DC. Maybe. Yeah, doesn't matter. But the point is that we're mapping the city not based on what we think the city boundaries should be, but based on what the elements of the map are saying, right? So when you think about Walkscore is this product that tells you wherever you are, how walkable is that region? Are you close to stuff? Is it easy for you to get around? Are you close to transit? Are you close to grocery stores? Things like that. So what if we mapped what if we mapped our city based on what the Walkscore was for any given area, as opposed to the boundary of the city itself? And furthermore, what if we filtered that based on bus routes, right? So this last example is basically taking WMATA API information about what routes buses take and coloring it by what the Walkscore is for every stop along that route. Not every stop, sorry, for every continuous location along that route. It's not exactly continuous, but there's a lot of data points. And so what you end up with, I don't necessarily think I need to go into the details because it's very similar, right? We're just going to define a different kind of API query to WMATA, define the request to Walkscore, make sure that we cache everything, and then all the magic happens. Here you can see that we're kind of iterating through all the pins that we get and getting the Walkscore for each pin. And then some other boilerplate stuff. And then what we'll get out is this part where we can just select a route and get the route scores for that route. And hopefully we get something like this, like a series of latitudes and longitudes and what the Walkscore is for each one. And then we can use Folium color line to actually go and take straight from our pandas data frame a certain column and treat each one of those column entries as long points on a line to be plotted. And what you get out of that is something like this, where I've added the population back in, but that's toggleable. And so this is Route L2 in DC that goes from Friendship Heights down to Farragut Square by the White House. And so you can see the Walkscore for all along that route. And you can see where in this city is not very walkable, where is walkable, and where do the buses go? So there's an exercise in this notebook after this. You can cycle through a bunch of the routes. You can look at the routes that go over the Anacostia River to southeast and see, you can maybe even categorize these bus routes by looking at these walk scores as, are they bus routes that connect places where people are already close to stuff? Or are they places that are like taking people in and out of areas that are not walkable, right? Like, is this a bus that's meant to get people out into and out of a zone that doesn't have a lot of stuff? Or is it just like a way to carry people around on their way to work? And you can imagine, you could make heat maps using this. You could do anything, anything you felt like with this data. So that's basically what's in this notebook. Yeah, so does that make sense? Cool. Yeah, it's pretty straightforward, and it's a little bit more hacked together than like using something like Dash, which would be very awesome. But I just wanted to show how easy it is and how much power you actually have in Python to go and pull all of this stuff from all these really cool data sources and libraries and technologies out there and just kind of like mush it together and make a product. So the last thing I'll say, and I'll stop for questions because it's been half an hour, is this is a product. So because this is in Python, we can deploy this on Heroku. Heroku is just one of the last remaining free hosting services. They actually have this thing where they'll spin up your application only when people visit the site, right? So if I want to go look at this application online, I'd be in my best interest to refresh this page to make sure the application is actually alive right now. And so what I did is I took the bus tracker part of this and put a front end on it that asked people for the location and the radius part of the equation. And then the application reads that from the form. It makes the API call in the background. It makes the Folium map. The Folium map is just JavaScript. So then Flask can just go ahead and render that JavaScript. So what that looks like is if I want to click on I don't know, L'Enfant Plaza, search radius. And so there it is. And these are actually live buses now going to Dulles, going to Foggy Bottom. Partially that's because Heroku is not very good at caching. Heroku's file system is kind of ephemeral and read-only. So you can't like save stuff on Heroku's file system and expect it to be there after the Flask request context is stopped. So that means caching is trickier. You have to like save stuff on S3 or you have to like figure out other solutions. But because I figure nobody will really ever use this app, I'm kind of okay with it. But yeah, and we can, after this talk is over, if you're interested in the code is all on the GitHub. Like I said, there's two parts to it. The demo is what I walked through the notebook, and the tracker is the Flask application. And yeah, so I'm happy to take any questions about any of this. See if we can get it to break. It's Sunday, people. What is going on here? Yeah, so let's put in a location we know won't work, like maybe the National Zoo. I don't think OpenStreetMap will be able to parse National Zoo to an actual address. So it hits the geocoder error page.
Are there any
Yep.
rules of granularity? Sorry. In terms of like neighborhood locations, I guess city and state are simple enough, but when you're zooming in and you want to drill down in the specific neighborhoods, are there any like guidelines or like rules on how granular you can get?
Yeah, so how granular can you get with like the shapes when you're like not at the state level, but you're like maybe on the neighborhood level? And yeah, that's kind of one of the challenging parts about working with this kind of data is that you need the shapes, right? It would be extremely painstaking to go and like look up latitudes and longitudes for some custom shape that you wanted to draw around your house or something like that, right? So often we rely on shape files from authoritative sources. So like the census data that I showed you, they also provide, they have like certain shape files for different regions. Like they have voting districts, they have other kind of like political boundaries, and you can kind of like get these shape files and use tools, like there's some mentioned in the notebook, but you can use these tools to like convert them to GeoJSON, and you can like make it so that you can use those shapes in Python, essentially. And there's a lot of like GIS related Python tools that will help you do that. But you basically need to find that file. So like these neighborhood boundaries that I showed you, it's because I found somebody who had gone to the trouble of like making a shapefile for neighborhoods. But that's the only limit. You can go as granular as you want.
Have you ever tried to like put colored points or like color data on the maps?
Yeah. So I showed you a few of the things which I ended up thinking looked the best, but you know, Folium has a lot of different options for putting markers on maps, for making heat maps, for making shapes on maps, all sorts of stuff. And it's extremely customizable because it's just hitting the Leaflet API. So anything Leaflet can do, you can do in Folium also. And I just happen to think certain things are cooler than others, so I wanted to do them. But yeah, you can do all sorts of stuff.
I guess I mean, is it easy to put like matplotlib color schemes onto a Folium map? Or like, the map is JavaScript, right? But the data that you're like trying to visualize, what is matplotlib's color scheme? Like, try doing that at all?
Yeah, so I haven't tried doing that, but like you saw how we used a custom color palette, right? So we could just replace this color palette with whatever palette matplotlib has. And yeah, so something like this. And so like the way that this color is getting onto the map is through like color and fill color. Like these are attributes of like some CSS style, probably somewhere deep in the guts of this thing, that's like choosing what color to make the regions and what color to make the points. And you can change these to be programmatically set based on whatever you want, right? So you can have them be static, you can have them be dependent on some Python function, you can have them be dependent on whatever matplotlib tells you, you can have them be dependent on what the user inputs, and then have the user say, I want the color scale to be this, and then it will redraw the map in that way. So all of that is completely customizable.
Okay, if we don't have any more questions, let's thank our speaker.